When we look at our solar system, Saturn stands out, not just for its rings, but for a fascinating paradox. It's a giant. Over 760 Earths could fit inside, yet it's surprisingly light. How can something so massive be so lightweight? This question challenges our assumptions about planets and leads us to the heart of planetary science. On Earth, size usually means weight, but Saturn defies this logic. Saturn is a gas giant made mostly of hydrogen and helium, the lightest elements in the universe. Its immense size is matched by a surprisingly low mass for its volume. To understand Saturn, we must let go of our earthly expectations. Its diameter is more than 9 times Earth's, but its composition is what truly sets it apart. Saturn's story is one of gas, pressure, and the delicate balance of gravity. The answer to its paradox lies in the unseen forces and materials that shaped it over billions of years. To unravel this mystery, we must look beyond the surface and into the heart of a gas giant. Imagine a world with no solid ground. This is Saturn. Unlike Earth's rocky surface, Saturn is a vast sphere of hydrogen and helium. These light gases make up nearly all of Saturn's mass, explaining its low density. When we observe Saturn, we see only the tops of its swirling clouds. Descend into Saturn and you find no surface, just increasing pressure and temperature, with hydrogen eventually becoming metallic. Saturn's gaseous nature makes it fundamentally different from rocky planets like Earth or Mars. It formed in the cold outer solar system, sweeping up abundant light gases. Its immense size comes from the sheer volume of gas it accumulated. Saturn is more like a felt star than a scaled-up Earth. Its airy composition is why it's a giant in size, but a featherweight in density. This sets the stage for Saturn's most famous and mind-boggling trait. To understand Saturn, we need to grasp density, how much mass is packed into a given space. Think of 2 boxes, one filled with rocks, one with feathers. Same size, but the rocks are heavier because they are denser. Earth is dense, made of rock and iron. Saturn is the least dense planet. Its average density is less than water. This means Saturn is huge, but with its mass spread thin, even though Saturn is 95 times more massive than Earth. Its vast volume keeps its density low. Saturn's low density is a direct result of its composition, mostly hydrogen and helium. It's a giant, but it's not heavy. Saturn's density is so low it could float in water if we could find a bathtub big enough. This thought experiment captures Saturn's unique nature, a giant planet that would bob like a bath toy. Of course, in reality, Saturn would break apart in water, but the principle remains. No other planet in our solar system could do this, not even Jupiter. Jupiter, though also a gas giant, is denser and would sink. Saturn's floating ability is a direct result of its puffy, gas-rich composition. It's a fun fact, but also a profound clue to its internal structure and history. Saturn is less compressed than Jupiter, hinting at a different formation story. Its buoyancy is a beautiful illustration of a complex reality. Saturn reminds us that the universe is full of wonders that defy our expectations. Saturn's low density is shaped by more than just its composition. It's a story of internal structure and gravity. At its core, Saturn likely has a small, dense center of rock and ice, but it's tiny compared to the planet's size. Surrounding this is a vast ocean of metallic hydrogen created by immense pressure. This metallic hydrogen helps generate Saturn's magnetic field. Above that lies a thick layer of liquid hydrogen. transitioning into the gaseous atmosphere we see. Saturn's rapid rotation causes it to bulge at the equator, increasing its volume and lowering its density. The planet also radiates more heat than it receives from the Sun. Helium rain inside Saturn releases energy, puffing up the atmosphere even more. This thermal expansion keeps Saturn's volume vast and its density low. The interplay of gas, gravity, and heat creates a planet that's both massive and surprisingly light. Saturn's structure is a delicate balance, a true symphony of gas and gravity. This is what makes Saturn so unique among the planets. Saturn's story isn't complete without its moons, over 140 of them, dancing in a complex system. These moons help scientists measure Saturn's mass and map its gravitational field. By tracking their orbits, especially with data from Cassini, we learn about Saturn's interior. Some moons, called shepherd moons, shape Saturn's rings, keeping them sharp and defined. The moon Mimas, for example, creates the Cassini division, a major gap in the rings. The intricate structures in the rings are a result of this gravitational interplay. The moons and rings are locked in a delicate dance evolving over billions of years. Studying this system reveals Saturn's true nature and its surprisingly low density. The moons are not just companions, they are keys to understanding the giant they orbit. Their graceful waltz tells the story of Saturn's mass and its featherweight paradox. Among Saturn's moons, Titan stands out. A world larger than Mercury, with a thick, nitrogen-rich atmosphere. Titan's surface is hidden by orange haze, but exploration has revealed lakes and rivers, not of water, but of liquid methane and ethane. Titan's methane cycle mirrors water's water cycle, with rain, rivers, and lakes. The Cassini spacecraft mapped these features, showing familiar landscapes made of alien materials. Titan's thick atmosphere and surface liquids make it a prime target in the search for life. Beneath its icy crust, a hidden ocean of water may exist, warmed by tidal forces. Titan is a natural laboratory for organic chemistry, with complex molecules forming in its atmosphere. It's a world with weather, seasons, and landscapes, more than just a moon. Titan adds another layer of wonder to Saturn's system. Here, a planet can float, and a moon can have rivers of liquid natural gas. Our understanding of Saturn owes much to the Cassini-Huygens mission. Cassini spent 13 years orbiting Saturn, transforming it from a distant point of light into a world of detail. It measured Saturn's gravity and magnetic fields, revealing the planet's internal structure. The Huygens probe landed on Titan, giving us our first look at its surface. Cassini's data confirmed Saturn's small core and deep atmosphere, explaining its low density. The mission ended with Cassini's dramatic plunge into Saturn, protecting the moons from contamination. Even in its final moments, Cassini sent back data, giving us our first direct sampling of Saturn's atmosphere. Cassini's legacy will fuel discovery for decades, a lasting echo from the void. Despite Cassini's success, Saturn remains full of mysteries. The age of its rings is still debated. Are they ancient or surprisingly young? Saturn's winds are among the fastest in the solar system, but what drives them is unclear. Measuring the length of a Saturnian day is tricky, as the planet has no solid surface. The Great Hexagonal Storm at Saturn's North Pole is a geometric marvel, still not fully understood. These puzzles remind us how much there is left to learn. Saturn challenges our assumptions and expands our sense of what's possible. From its floating potential to Titan's alien landscapes, Saturn is a source of endless wonder. It beckons us to return, to send new probes, and answer the questions that remain. The Lord of the Rings still holds many secrets, waiting for the next generation of explorers.